Just 1 second. There you go. So yeah, well, welcome everyone. Thanks a lot for the intro, Bogdan. As you said, my name is Johannes, and I'm with Nerif. And basically, what we do is we make Web3 developer experience suck a bit less. And today, I want to show you basically why Web3 DevX sucks. But I assume many of you already know a bit why this is the case, just because of personal experience, and what we can do about it to change that. Now, how does a DApp actually look like on a kind of more abstract level? And if you think about it, right, you have always some kind of blockchain, some kind of back end, if you want to say, where the data is stored, where things are processed, which is your infrastructure. And then on top of that, you have your smart contracts, your business logic, your actual application. And then the other thing you need a user interface or something with what the users, the end users of your application can interact with this set of smart contracts with your business logic. Now that's just a very abstract kind of representation of how it would look like, but reality looks quite a bit more like this. And just a question to you guys: who in here is a builder? Who's on the technical side? Just for me to understand. Just a quick raise of hands. Ah, cool. Very good. Very good. So you know that, right? If you want to build an application that is rich to use, that has more than just kind of the bare bones, you need all those parts. You might want to send out notifications. You might want to do cross-chain interactions. You might want to deploy your application multiple chains because you want to reach kind of a wider audience, or you want to make it gas efficient because Ethereum might be too expensive for certain parts of your application, so you put it on a layer 2, but then you have to move it back and kind of keep those two things somewhat in sync. You also might want to have to integrate off-chain stuff, or send off-chain things, or do just multiple things. That's like a real headache, and I have a very good example here. So I talk a lot about tacos. I love tacos, that's why. But so we actually started this kind of as a way to build our little developer community, because that's what we're all about, right? We want to bring builders together to build better applications, to have a good time, to make Web3 successful. And when we started this event series, and we actually changed that because of exactly that problem, we used a tool called Unlock Protocol. Now, Unlock Protocol, what it is, it's actually really cool. It's a set of smart contracts and kind of a user interface which allows you to create event ticketing based on NFTs. So far, so good. It enables a lot of things which you can do then with that. Token gating of groups, token gating of future events, and. The problem is that the user experience is just not there yet. And that is not necessarily Unlock's problem. That is a problem which we have on the infrastructure side. And I just show you one example. I can't open that here now, but we had that problem that you can deploy your contracts on Unlock actually across different chains. You can do it on Ethereum, you can do it on Polygon. The issue was that, let's say for like a low value event, like a taco dinner, you don't want to spend $50 worth of gas to mint the ticket. So kind of mainnet is out of the question. So what we did, we deployed it on Polygon. Well, so far so good. Then the problem came, okay, people wanted to mint their tickets. And actually back then we charged a little bit for those tickets. So it was like, was it 10 USDT or something? And typically, when do people get those tickets? It's when there are events on the road with their phone. They don't use their computers. And we had the problem that, well, actually I ask you, so how many of you have a wallet on your phone? Everyone, okay. How many of those who have a wallet on their phone have something on Ethereum, like some Ethereum assets, USDT, ETH on mainnet? Okay. How many of you have Matic on their phone? Well, actually quite a lot. That's surprising. But what we saw is that a lot of people, they had some ETH or something, but they didn't really have, like, also, they might have some Matic somewhere, but not on their phone. So they couldn't actually get the tickets because they would have to bridge those ETH into Polygon first. And that just broke the user experience completely. So it didn't really work. We had to stop using it. But one of the kind of the outcomes of that is that, hey, you know, actually this cross-chain interactions, this automation matters. And that's really what we do at Ethereum. So what to do about that, right? I mean, we can sum up. Those non-core parts, they're not really core to your smart contract. They make development a headache. They're also really expensive. Typically about 20% of the maintenance cost, not of the development cost, of the maintenance cost, in a large and more mature DApp is this kind of keeping this plumbing alive, keeping it up and running, updating it, just, you know, working with it. And it's very repeatable. Every application uses some of those same processes. Everyone wants to send out a notification. Everyone needs to do some kind of maintenance. So we said, hey, let's automate it. And that's what we did. So we built Nerif Network. And what is it? It's a tool which kind of sits by your side as you build. So, you know, you have VS Code or your IDE of choice. You might use Remix for deployment and testing. You have some, you know, a security suite like Hardhat or Truffle or whatever your flavor is. And then you have Nerif, which just kind of makes those little interactions, for example, being able to connect a application of Polygon to payments on Ethereum mainnet or other things, very, very simple. How does it look like? Like this. So it's two parts, right? We have built a network, which is not a blockchain, but it's a separate physical layer. And what it does, I think I even have, oh, that's really cool. What it is, it consists of several nodes, and they have a consensus mechanism in between themselves. And what it allows to do with some cryptographical primitives, it works completely trustlessly. So those nodes, they make sure that whatever you deploy from the app, which is what you will just see in a minute, is executed exactly how you program it, and you don't have to trust any centralized party. You don't have to trust, don't run any counterparty risk. You don't run any platform risk on that. If you go a bit deeper, right, that's kind of the very basic consensus mechanism, if you will, is that every node executes kind of those smart contracts, not smart contracts, those workflows you deploy, and they create a signature. And this signature alone doesn't do much. But then we use a concept called threshold ECDSA. I'm not sure, maybe some of you have heard of it, which allows the network as a whole to create an aggregate signature, which is valid only if at least 2/3 of the nodes basically provide the same payload and the signature that, or their signature to that same payload. And the cool thing is, this is then verified on chain, so you don't have any kind of point of trust you have to have in between in here. And it also makes it super, super gas efficient, so we can run this whole network, and it doesn't cost us any gas because all the computations here are done off chain, but are only validated on chain, and it is as efficient as if you would basically directly execute it on chain and not have this whole network behind that. Okay, enough of the theory. Let's build something. So I just want to, very briefly show you how kind of this whole thing work and what I will build now. And actually, I have a video. I'm not going to build it, but because I don't have a computer. But is a lottery contract, and it's a game. It's straightforward. It has two functions. As a user, you can put money into the smart contract. And once, for example, every week, we're now going to execute it once every minute just for demo purposes. But once every week, you want to do an automatic drawing where all that money, which is in that smart contract, gets pooled and gets sent randomly to one of the winners, the winner of the lottery. It is deployed on Polygon Mumbai, but the whole thing is cross-chain. So you could do that on any chain or even in between and allow players to play from different chains. So yeah, so please production, play the video. Oh, that's not even changed here, sorry. So I actually have to check up here. So we have the contract, which you can see it has a function, oops. It has, I have to see it myself here. Is it, so you have the function enter, right? Which allows you to pay into that application. And then you have a function players exist. It's just, we'll see that in a second, which checks if there's enough people. You don't want to execute it for gas reasons if there's less than 2 people. And we have one called pick winner, which randomly selects all of the players and pays out the money to kind of one of them. So we have now defined this. So we can go to the Nerif application, just log in. And this is the overview page. And we will create a new workflow. We'll call that lottery. And all we have here, we have triggers. So all the workflows are basically triggered by something. It can be an event on any chain. Now we're using a cron rule because we want to execute it once every minute. So select that, configure it. I do it once a minute, so just put in 1 minute there. And then what we want to do first, we want to actually read the chain. So we want to first check, hey, is there enough players in that game to make it work? So we select the chain, Polygon Mumbai. The whole thing is live on 5 chains, so you can really, mix and match there. I'll get my contract address of that application. Paste it, and then I execute this players exist function, and it returns a boolean called exist. And that just, if it's true, it's more than 2 people. So I can do that. I add now a condition, and I just, check if that variable I got, this exist, is true. If this is not the case, we don't have enough players, so we don't want to waste gas. So we go out. And if there is enough players, now what we want to do, we now want to make a state change. So we select the transaction, and we select the same chain. It's Polygon Mumbai, right? Because you're only interacting with one smart contract in this example. It's the same address. Now we have to put a gas limit because we're actually, executing that function and changing the state. And we use the pick winner function. And that's actually all I need to do to automate that and to have a very rich and kind of fully working application on the Nerif network. I'm deploying it now to the network. Takes a while. I'll just cut it out here, actually. So that's it. So you can see it's going to change to active in just a second. Perfect. So now we have this workflow which is executing once a minute and checking if there's enough players. And if there's enough players, it's going to pick a winner. So let's do that. I will now go to my user interface, which is just an Etherscan. I connect my wallet. And I execute the enter function with 0.2 Matic. I will then change my wallet and play with another wallet, also 0.2 Matic. So now I have 2 players in that game. We can see that in the overview. Like they entered both. And if we now go into the internal transactions, we can see nothing happened yet. But if we wait a minute, and we can go back to see that on the Nerif side as well, we can see, oh, now a winner has been picked. And if we go into the transaction, we see that 0.4 Matic have been sent to the winning wallet. And that's the whole magic, right? And this kind of allows you to obviously build a lot more complex applications as well. You can switch back to my my presentation, please. And just kind of have the backend and all that plumbing of your DApp just taken care of. So that's kind of what I wanted to show you, and I want to open up for some questions. Maybe you have some ideas or some insights. And one super important thing, the whole thing is live. It's currently waitlisted, so it's not publicly accessible. But because you are so cool and all came to my talk, I would love to give out some priority access codes here. So if you kind of go on a waitlist and you use that referral code, you will be put on somewhere on top of the list. and you can get access quite soon to Nerif and really try it out yourself. And always very, very happy to hear some feedback from you. Cool. Thank you so much. Two more things. After talk, the ones who haven't been here, if you have not been approved yet for the taco tonight, please come to me. Let's do that. But first, let's discuss actually a bit about Nerif. So, any questions from the audience so far? All clear. Oh, it's not sure if that's good or bad. Sure. Yes, please.
So to sum up everything we went through in the demo right now, can you compare like what would the UX for the user look like with and without Nerif?
Sure. So let's imagine what we would have to do to build this without Nerif. So you would have to have some kind of server running somewhere, because the thing is the blockchain doesn't execute itself. So if you want to do a drawing once a week, you have two ways on to do that. You can either kind of build a, let's say, an incentive where the contract is built in a way that the first person who executed within that time frame gets 10% of the winnings. That's what is actually usually being done at the moment, where you kind of incentivize those things. A good example might be in DeFi, the liquidation mechanisms, right? It doesn't liquidate itself. Someone has to actually go there and do it. Or the other way is, as kind of the company running this lottery, you could run a server where you have a cron shop on top, but then what you need to do is you need to either run a node or use a subgraph or kind of something where the blockchain data is actually pulled. And then every time you have a cron job which starts that, which talks to the blockchain, checks, hey, is there players in the game? And then you also have to have a wallet on that server which has some money on it, because you then have to execute that transaction. So you have to also build a secure kind of ecosystem where you manage your wallet. You have to make sure that there's always enough kind of money on that wallet to pay for gas. And this is extremely simple thing to do. But imagine like how many components do you actually need to build to just make this work? It's probably about 10 too many. And then you have to maintain it, because then things are outdated, or you have to keep, let's say if you run a node or depending how you set it up, right? Or there's like your wallet is becoming unsecure, so you have to make sure that you bug fix and because this is kind of generic infrastructure which we need to have with Nerif anyways, and most like the whole secure part, so kind of the billing and payment is all on chain, because it's a set of smart contract which wouldn't make sense to build for yourself, because it's going to be very expensive from a gas perspective. But for us it doesn't matter, because we scale it. We have the same infrastructure kind of for everyone executing applications. It's even more secure. It's substantially more secure than running it on yourself. It's the same idea of, I was, you mentioned it, I was spending quite some time also in kind of the investment space and the building space. And there was always this question, well, should we have our own servers, or should we basically use a cloud server? And I always claim, hey, actually, probably the Microsoft security engineers, they're quite a bit better than the security engineers, which we don't even have in-house. So it'll end up being more secure, even though it's on the cloud. So it's kind of goes into the same direction.
Thank you.
Welcome. Any other questions so far, or any ideas what you could build with it, actually? Very good. I think everyone is just... Oh. You have a question?
I'm not quite sure if it's the right question, because I missed the beginning of the talk, but probably Open Zeppelin has a tool that's checking transactions on the blockchain. Would Nerif be suitable for that, or is it a complete another use case to mitigate security, or I don't know, maybe other use cases?
It is partially comparable. you could say it's kind of a small subset of what Nerif does. So you can, in a sense, you can build the same with Nerif than what you can build with the opens. I think they're called functions, right? OpenSimple, yeah. But it does a lot more. And because you have this separate physical layer, this infrastructure, it's kind of more all-encompassing and decentralized. Follow-ups to that? Super.
Awesome. Thank you so much.
Thanks a lot for coming. And yeah, I'll be down here. So if come here with your tickets.